Good morning, girls. Good morning. How are you? Okay, today we are starting in a new lesson 16.3. We jumped. Lesson 16.2 is cancelled, so we jumped right away from lesson 16.1 to 16.3. 16.1 was done successfully, and for the classwork that I left you, I will be uploading a picture of all the work explained for all the classwork. If you still have any doubt, and please, if you don't understand anything, just message me. Okay, our new lesson is called Representing and Describing Transformations, and we are in page 801. Representing and Describing Transformations. Transformation, we have been hearing this word a lot. What is a transformation? As you can see inside your book, it's said a transformation is a function that changes the position, the shape, and or size of a figure. Which means what? Can you see this figure that we have here? This is a figure. When I get this figure and start moving it around, changing its position, changing its shape, putting it here across x-axis, across y-axis, all of these things are called transformation. Transformation is when you are changing something about your figure. This is a transformation. So as you can see here, the transformation is or might change the position. Yani instead of being here, it can go up, it can go down, it can go left, it can go right. It can change the shape. It can change the size. You remember, I can make it stretched or shrinked. How many transformations we have? We have 4 main big transformations. That all is written here. The transformation that affect your figures are: the first transformation we have is translation. Translation is the easiest and basic transformation that we have on any figure. Translation means when you translate or when you move your object around. This transformation or this translation can either be up, when I get the figure and move it up. It can be down, move it down. It can be right, it can be left. So the movement can be up, down, right, or left. This is the meaning of translation. For this translation, try to imagine this figure being translated around. This is a square, right? And each angle in here is 90 degrees. When I translate it upward, for example, will the square become a triangle? In other words, will I change the shape of my figure? I won't, right? Will it change the size of my figure? For example, this was 3 centimeters. When I move it up, it will become 9 centimeters for any reason? Never, right? So actually, translation changed nothing in my figure except my position. This was 90 degrees, the angles. Will the angle change by translation? Again, no. The square will remain square as it is. The only thing that will be changed is the position. So the transformation is not, it doesn't have to change all of these 3. Each transformation changes something. So the translation only change what? Position. Only change position. The second transformation we have is reflection. Reflection, as you can see, I wrote here a mirror, which means what? What is a reflection? Reflection as if you are seeing yourself in a mirror. This is a reflection. When you see your reflection in the mirror. For example, if I have this square and I'm trying to reflect, imagine that there is a y-axis in here, an imaginary y-axis in here. What will happen to my square if I'm reflecting it across y-axis? It will come from here, and my y-axis is the mirror. This is what will happen. So my figure or my triangle will, or my square will become in here. What about if I'm reflecting across x-axis? What will happen to my figure? It will go down, right? This is the meaning of reflection. This is the meaning of reflection. Again, try to think. I reflect my figure. I reflect my square from here to there. From here to there. Will it change the size of my square? My square will get bigger or smaller? No. Will it change the angles of my square? Again, no. Will it change the size? No. Will it change the angles? No. It will never change anything except, again, position. Instead, it was here, it will become in here. It was here, it will go down if it's across x-axis. So again, Translation and reflection, we can write here that both of them change position only. It doesn't change size, it doesn't change angles, it doesn't change sides, it changes nothing but position. The third one is the rotation. Rotation means rotation. Rotation as if you are seeing the fan. You know the ceiling fan? You know the ceiling fan? Most of you know the ceiling fan, right? The ceiling fan movement is called rotation. This is the rotation. Is when you have an object centered in between, centered, and this object, the center of rotation, this is called center of rotation. Center of rotation. This is the center of rotation. As if the center of the fan in the ceiling, it's not changing, it's not moving, but everything around it is moving. This is rotation. This is rotation. Is when you rotate and move in circle around a center of rotation that never moves. Okay? The rotation happens in two kinds or in two movements. Either this direction, which is called clockwise direction, you remember? Clockwise when you are moving with the clock, or it can happen in the other direction, which is the counterclockwise direction. And you remember the 90 degree and 180 degree. Anyway, if you don't remember, we will be taking this in small details, so don't worry. In module 17 we will be taking all of this again, so don't worry if you don't remember it. But for now, just understand that the rotation is when you move an object in circle around a center of rotation like the ceiling fan, and it happens in two directions, either clockwise or counterclockwise. CW is clockwise, CCW is counterclockwise. Okay? Again, remember, the ceiling fan, when you are moving the ceiling fan, will it change size? Will it change the shape of the fan? Will it change the angles of the fan? Never. So again, rotation actually change only position. And actually it changed something else, but not for now. It changed the orientation of the object, but not for now. Just for now, understand that it is not changing the size of the object. The fourth one, which is the fourth transformation we have. So we talked about translation, we talked about reflection, we talked about rotation, and we said that these three do not change anything, they only change position. Going to number 4, which is dilation. Dilation is when you shrink or you stretch your object. Stretch have another name, which is enlargement, is when your square here gets bigger. Instead of be 3 by 3, it will become, for example, 6 by 6, 9 by 9. It will get bigger. Reduction is another word for shrinking, is when your square gets smaller. So here, instead of being 3 by 3, for example, it will become 2 by 2. It will get smaller. This is called reduction. This is the only translation, this is the only transformation that you have that will change shape and size. This is the only transformation that we have that will change shape and size. Any other thing only change position, as we said. Okay? According to this is a very, very, very important note. Girls, please, if you can try to put this on a piece of paper or inside your books in a sticky note or something, because this page actually all is very, very important. I will be uploading a page for a picture of this on Class Dojo. So for now, we understand the transformation are 4: translation, reflection, rotation, and all the first 3 only change position. And then we have dilation. The dilation change the shape and size. The dilation have 2 forms, either enlargement, which is stretching, or reduction, which is shrinking. This we heard about it from grade 8. The new thing, These four transformation can be divided into two big forms or two big kinds. The first one is called rigid motion. The second, so we were talking about the rigid and non-rigid motion. But I was telling you what is a rigid. Rigid thing means when you hold something in your hand and it's not being bent. You cannot bend the object inside your hand. This is called a rigid motion or a rigid object. Non-rigid object is that you can change its size, like slime. When you hold a slime in your hand, what will happen to the slime? The slime, you can do it like this, you can do it like this. It changes inside your hand, right? So this is the rigid and non-rigid. يبقى rigid is an object that I can never bend or change its size, like this laptop here, my laptop here. If I try to hold it inside my hand, will it change size? Will it bend inside my hand? It will never, right? This is called a rigid object. Non-rigid object is like the slime I told you about, or like the stress ball. You know the stress ball? When you hold this ball and start stressing on it, it changes size. It become bend inside your hand. Oh, this is called non-rigid object. So according to this, my translations or my transformation are two kinds, either rigid or non-rigid. Rigid means is when you apply this transformation on an object, it will never change size. Non-rigid, it will change size. That's why we can say the rigid motion that transform and move the figure without changing its size or shape or angles or side measures. Example, the first three. We said the first three, translation, reflection, and rotation. Did they change size? The square that we have in here, did they move this object and make it smaller or greater or whatever? Never. That's why this is called rigid motion. Non-rigid motion is dilation. Why dilation? Because dilation is the only transformation that will change the size of your body or the size of your object. That's why it's called non-rigid motion. Why is this important? From now on, for any transformation or for any question that you are going to be having, he's going to be asking you what transformation is happening here and what kind of it. What kind, and you have to tell him, is it rigid or non-rigid? The last thing that we need to know as a note before we start our solving is this. I know that we took this before, the word pre-image and image. You have a figure, and then you are going to apply a certain transformation on this figure and start moving it around, up, down, left, right, reflect, whatever. So after you move it, you will be having one object in here and another object in here. For example, the first object that you started with, the original, is called pre-image. Pre-image. This is called the original object, which is the pre-image. The image itself, or the secondary object that is transformed, is called the image. But for any transformation, we are going to be having two figures. The original figure is called pre-image, and then you apply a certain transformation on it, one of the four that we said about, and then you are going to be having the other figure, which is called the image. To differentiate between the pre-image and image, always the pre-image is going to be named by its original name, A, B, C, whatever, and the image is going to be the same but having this prime ahead. Can you see this thing in here? This is called prime. So whenever I see A prime, B prime, C prime, whatever, I know that this is the image and that the one without the prime is the pre-image, the original one. Okay? Okay. Let's start to solve question A in page 801. Let's read the question. The question is saying, find the unknown coordinate for each transformation and draw the image, then complete the description of the transformation and compare the image to its pre-image. And as if you don't see this red thing, I will tell you what, I will open the student edition because I don't want you to see this, the solution. I want you to do it by yourself. So let's open the student edition. Okay. This is the question. Find the unknown coordinates for each transformation and draw the image, then complete the description of the transformation and compare the image to its pre-image. And I have this here. I have a triangle ABC. ABC without primes. So this is the pre-image. This is the original image that I'm going to do a certain transformation on it and start moving it around on the coordinate plane. And you are required to apply this transformation on this figure and then draw the new image. And this is the transformation that we need to apply. X and Y will become X minus 4 and Y minus 3. What is this? This is called the coordinate notation. You remember in grade 8 we had some coordinate notation that we needed to memorize for each transformation. We had a coordinate notation for reflection, for translation, for rotation, and even for dilation, right? The same thing is happening here. Here he is telling you what will happen to each point inside your pre-image. You know that any point is known by what and what? X and Y, right? So for any X and Y, you have to do this transformation. X will become X minus 4 and Y will become Y minus 3. What should I do? Look with me. Whenever you have a question like this and he is giving you the transformation itself, what I'm going to do is that I'm going to extract the points A, B, C, because I need to draw the new image. So I need to find A. What was the coordinate of A? It was whatever, and then I will apply this transformation and then I will find the new A. What is the A? Let's extract A, B, and C. A, B, and C. What is the coordinate of A? A is 0 in X and 4 in Y. As you can see, it's 0 in X and 4 in Y. So here we can write 0 and 4. What about B? Yes, it is 3 in X and 0 in Y. So it is 3 and 0. What about C? C is the origin itself. C is here. The origin itself, which means it is 0 and 0. Okay? And then let's apply this transformation. So, X should be X minus 4. 0 minus 4, right? So X will become 0 minus 4. And Y will become Y minus 3. So 4 minus 3, which is 0 minus 4 is negative 4. 4 minus 3 is 1. 3 and 0 will become 3 minus 4, 0 minus 3, which is negative 1 and negative 3. 0 and 0 will become 0 minus 4 and 0 minus 3, which will become negative 4 and negative 3. This is A prime, this is B prime, and this is the C prime. So A maps to A prime. Yani A was 0 and 4. It become negative 4 and 1, which is A prime. B become B prime and C become C prime. And then what should I do with these 3 points? I should graph them. I should put them. Negative 4 and 1. Where is negative 4 and 1, for example? If I'm trying to graph it here. Negative 4 and 1. This is negative 1, negative 2, negative 3. So negative 4 will become here. And 1, I should go up. But this is A prime. B prime is negative 1 and negative 3. Negative 1 and negative 3 down. So it will become in here, for example. This is B prime. C prime, negative 4 and negative 3. Yani negative 4 and negative 3 down. So it become in here. Sorry that it's very messed up because I don't have a space. So this is my new triangle. So my pre-image, this is the pre-image, and this is your image. Can you tell me what is the name of this transformation? Is it rotation? Did it move like the ceiling fan? It didn't, right? Is it reflection? No. It is what? It's translation. It moved down and it moved left, right? How many units? let's go to the original one because it's more clear. طبعا you are going to do this inside your books, so you should have something like this. So in here, this is my pre-image and this is my image. What happened to my image? Can you tell me? You are going to see any point, either A or B and C, and start tracing it from the pre-image till the image to understand what happened. Let's talk about A. Let's take A and talk about it. Point A was here, and then it moved left. Let's count how many points left. 1, 2, 3, 4. So 4 units left. And how many points down? Sorry, 1, 2, 3. So from A to go to A prime, it moved 4 units left and 3 units down. And this is what I wrote here. The transformation is a translation. Since I am moving, so this is a translation. 4 units left, as we said, and 3 units down, as we said. The last part of the question, يبقى كده find the unknown coordinates. We did it. We found the unknown coordinates. And then draw the image. We drew the image. And then complete the description. We completed the description. And then compare the image to its pre-image. Compare means what? Tell me what happened to the shape and size of the image and the pre-image. Tell me, what do you think? Is the shape changed? The shape is the same, right? Is the size changed? Again, the size is the same, right? So this is what I wrote here. The image is the same size and shape of the pre-image. Yani when he is asking you about comparison, just tell him what happened to the shape and size. Type. I will do another one with you. Before I go, what do you think? Is this a rigid or non-rigid motion? This is an important question. It's not written here, but you write it as a note. This is rigid or non-rigid? We said rigid when it keeps position, the size the same. If the size it changed, so this is non-rigid. Is the size the same? The size is the same, right? So this is a rigid motion. So this is what I am going to write in here. This is a rigid motion because it only changed position, but it didn't change the size of the object. So this is a rigid motion. Let's go to the second page. I'm going to do question B with you. Question B. Again, going to the student edition. In question B, you have, this is your image, this is your pre-image, and this is the transformation that I should apply, that x and y will become negative x and y. As we said, the first thing I should find is the coordinates of the 3 points. So let's find the coordinates of the 3 points. Let's find R, S, and T. R is what and what? You will see it is -4 and 3. S is, again, it is -1 and 3. T is -4 and 1. Let's apply this transformation on it. This transformation is saying what? That y will remain y as it is, but x I will put a negative sign. Or in other words, just put a negative sign. So let's put a negative sign. If a y will become as it is. So 3 will remain 3. Let's put a negative. -4. So it will become a 4. What about t? 3 as it is again. What about -1? So it will become a 1. And then one will remain 1 as it is, and -4 it will become a 4. And then let's put them on the figure. So I have 4 and 3. Let's count. 1, 2, 3, 4 and 3. طبعا you understand that this is R prime. This is S prime and this is T prime. So this is R prime. Let's draw S prime. 1 and 3. So this is S prime. T, 4 and 1. So this is T prime. So this is my image. So this is my pre-image and this is my image. Can you tell me what transformation is happening here? It's very obvious. It is what? It's the mirror. It's the reflection. Reflection across what? Y-axis. So if I'm trying to complete my description here, the transformation is a reflection across. If it was across x-axis, it will go down. Remember, x, it will go down. But here it went to the right, so it is across y-axis. So I'm going to write y-axis. But this is reflection across y. Let's compare between the image and the pre-image. What do you think here? Do they have the same size and shape or not? Yes, they have. It is the same size and shape. And this was 3 squares, it remained 3 squares. This was 2 squares, it remained 2 squares. Only it's looking in front of each other. But did it change size and shape? It didn't. So this is what I'm going to tell him. Size and shape are the same. So let me ask you, is this a rigid or non-rigid motion? It's rigid motion again because it didn't change size. It is the same size. So this is a rigid motion. You are required to do question C by yourself. I'm going to be waiting for question C as a classwork for today. It is the same idea. You have a certain thing and then you have to apply the transformation that you have, and then you have to compare, and then you have to tell me is it rigid or non-rigid as a note in here. Okay? So I'm going to the last part of this lesson. مش of this lesson of today. طبعا this lesson is still a long one, but we are just going to be taking an extra example. Here he is telling you that we have two kinds of motion, as we said, rigid and non-rigid. Rigid is here and then non-rigid will be tomorrow inshallah. But for now, what he is telling you here, he is telling you that rigid motion in here in this table, preserve. What is preserve? You understand what is preserve? Preserve, girls, mean keeps or maintain. Keeps. Okay? So the rigid motion is a motion that preserve distance, preserve angle measures, preserve betweenness, preserve collinearity, and preserve parallelism. And instead of all of this, you can just understand that it preserve what? Size. And that's it. Rigid motion preserve size. That's why the rigid motion is translation or reflection and rotation, because all of these doesn't change size. Okay? Okay, please now prepare your protractors, please, in front of you, because unfortunately we will be needing them. It's easy, but just prepare them, please, and then let's read this question. I'm going to do question A, and then you please try to do B by yourself, and then I will do it again tomorrow with you in another video, inshallah. The question is, use coordinate notation to write the rule. Write the rule. What is the difference between this example and the previous example is, in the previous example, he gave you the rule and we extracted the points and then we got the new points and we graphed them. In here, everything is graphed for you. The image and the pre-image. And the points are here. Just you need to do what? You need to put the rule itself. It is opposite. The rule is unknown. I have to imagine what is the rule and put it. So I need to write the rule that maps each pre-image to the image and then identify the transformation. By understanding the definition of each transformation, you will be able, if it's just moving, it's translation. If it's in front of each other, it's reflection. If it's like the ceiling fan, remember the ceiling fan, so this is a rotation. And if it's changing size, it's dilation. After understanding the transformation and identifying the transformation, I need to confirm that it preserves length and angle measures. Length, we are going to use the distance formula that we learned yesterday. What about angle measures? You are going to be using the protractor for this. Anyway, let's see the first example. Example A. This is what the question will be like. I have two figures. First of all, I have to ask myself which of them is the pre-image and which of them is the image. Because if you messed this up, the question is done for you. It's zero. Because you will be doing something else. This is another question. So the first thing, I have two figures. Which of them is the original one? Is it the one with the primes? You understand here I have A prime, B prime, C prime? Or the one without prime, A, B, C? Of course, it is the one without primes. I'm going to search for the one without prime. So this is my original. يعني I started here. What happened when I started here? My object become like this. Try to concentrate with me. This is my object. It came like this again. Is this reflection? Of course not. Is this a normal translation? Translation means that my object will just be as it is, like here, but moving up or down or left or right in the same shape and orientation. So this is not a translation. Is it dilation? Is it changing size? No. It is like what? It is the same shape as the ceiling fan, ya banat. It's doing a circle. So this is rotation. Is it clockwise or counterclockwise? This is what? Is it going with the clock or against the clock? Against, right? So this is movement counterclockwise. The rest is how many degrees? How many quads we have? We have quad 1, 2, 3, and 4. If any point, if your figure is moving one quad, so it's a 90 degree. If it's moving in two quads, it's 180. If it's moving in three quads, it's 270. If it's moving in four, it is 360. Let's take any point and trace it. Let's take C, for example. C was in quad 4, and then it moved one quad up. So how many degrees? This is 90 degree counterclockwise. Again, how did I know it's a rotation? Because it's moving like the ceiling fan. It's moving in circle. It's moving like a circle. So it's a rotation. How did I know it's counterclockwise? Because it's against the clock, the direction of clock. How did I know it's a 90 degree? I traced any point. I have 3 points. So I traced C, for example. What happened to C and C prime? It was in quad 4 and then it moved one quad up. One quad, so it's a 90 degree. But we can write this as a note also. We can write this here as a note. This is page what, by the way? This is page 803. So page 803. The first note we are going to write is for the rotation, movement one quad, so this is a 90 degree. Two quads, so this is 180 degree. Three quads, so this is 270, and 4 quads. This is impossible. This is 360 because moving 360 degree, the object will become as it is, will remain as it is. Anyway, كده we identified the transformation. So this transformation, as it's written here, I identify it's a rotation of 90 degree counterclockwise. Let's try to find the rule itself. In the example that I will leave you, it's written. If it's not written, the coordinates of the pre-image and the image, you have to extract them. You are going to extract the points from the image and the pre-image. A, B, C, and A prime, B prime, C prime. And this is my image and pre-image. A, 1 and 2, it become negative 2 and 1. B was 4 and 2, it become negative 2 and 4. 3 and negative 2C, it become 2 and 3. Can you try to think about what is happening? Can't you see that 1 is here? يعني the y, the x became the y in all the three, right? So what else do you note? The y became the x but with a negative sign. It was a 2, it become negative 2. It was a 2 again, it become a negative 2. It was a negative 2, it become a 2, because negative is positive. So from here I can say that my rule is, let's write it here, x and y, I put x instead of y. So here it's x, because as we said here, 1, which was x, become the y. So that's why I will write x instead of y. What about x? The value here. It is the same as y, but with a negative sign. So I can write negative y. But again, all of the values of x became the y. That's why I put here the x instead of y. And what about the value of y? It became the value of x, but with a negative sign. So it is a negative y. So x and y became negative y and x. This is how we can write the rule. So we wrote the rule. I found the rule. I still have to identify or confirm that it preserves length and angle measure. Let's see what about length. Okay, this is a long one. Preserve length, يعني I need to see if each length of side in the image, in the pre-image, is the same as in the pre-image. Which means, how many sides? This is a triangle. How many sides we have? We have 3. In the pre-image, I have AB, which become A prime and B prime, right? I have AB, and we have BC, which became B prime and C prime. And then we have the last one, which is AC, which become A prime and C prime, right? To confirm that it preserves the length, you have to use the distance formula for finding AB, BC, AC, and A prime, B prime, B prime, C prime, and A prime, C prime. But طبعا be smart, you are sure that this is the same. It didn't change size, right? Since it didn't change size, so all lengths will be what? The same. يعني AB will be the same as A prime, B prime, you are sure. BC will be B prime, C prime, you are sure. And AC, you are sure it's A prime, C prime. So just get the length of AB, the length of BC, the length of AC, and then it will become the same. يعني in other words, I can say this. AB will be square root, as we did yesterday, and then let's use the coordinates of AB. It will this is the coordinates of AB. So x2 minus x1 all square, which is 4 minus 1 all square, plus y2 minus y1 all square, which is 2 minus 2 all square. Under the square root, it will become 3. Without calculating A prime, B prime, you are sure it is the same. يعني just I'm going to write here, so A prime, B prime is equal to 3. I am sure. I don't need to reconfirm. I am sure because they are preserving length. And then I'm going to do the same thing for BC. Equal whatever. It will become square root 17. You are sure without calculating, yeah, just you are going to write, so B prime, C prime is right away equal to square root 17. And then the same thing will happen for AC. You are going to find its length. It will become square root of 20. Without calculating, A prime, C prime will be equal to square root of 20. يعني you have to use the distance formula once, and then the second one will be the same. So I used it for A, B, so A prime, B prime is equal to 3 right away. I used it for BC, so B prime, C prime is equal to square root 17 right away. I used it for AC, I have to use it here, I have to do the square root and then this, whatever. You have to use every part, and then you will find it is equal to square 20, so A prime, C prime will be right away equal to square root of 20. The last part, which is, I will tell you what, this is enough for today because this is a huge lesson for you today. So I'm going to leave the protractor for tomorrow because it needs very huge in concentration. So let's do it tomorrow, girls. We are going to stop here today. We stopped at question A. You can do question B, but leave the protractor part. For the protractor part in here, just leave it. Just complete all of here, and when you reach find the measure, leave it for tomorrow, inshallah. Okay? Thank you very, very much.